Okay, we're back. Now in the previous video, we built the character anim blueprint. We got it set up. In this video, I want to get that attached to our hero character so that we can see him animate. And then we want to set up the ability for this to also play death animations. And the way we're going to do that is if we take a look in our asset browser, we have 3 different death animations. There's 1, 2, and 3. They're all pretty much the same, but subtly different. We're going to set up a system that allows us to randomly select between them. So let's go back out here to our map. Actually, let's go to the hero character. If we take a look at the hero character's mesh component, over in the details panel, you'll see there's a property called anim blueprint generated class. This is where you plug in the animation blueprint that will drive this skeletal mesh. So let's plug in our character animBP, like so, and compile and save. And now if we play the game, check it out. He's running around. It's awesome. And if he rotates in different directions, his feet are still moving properly. So great, the animation blueprint is working, but if we let him get killed, he just still disappears. So let's set up a system that allows him to animate properly when he gets killed. Now, of course, the first part of that is making sure that you have enough time for that animation to play. So let's start off here inside the hero character, and let's find that branch of the graph that is handling when he dies. So right here, is dead has test true, so we immediately respawn the player. Well, instead of just spawning, let's instead do a delay. And let's say we delay for about 3 seconds. So a nice round number. We can always change it later. And so now if we compile and we play, so we can just kind of run around, and as soon as we die, we're technically dead right now. So we're just waiting 3 seconds and then we're respawning. But we're not behaving like we're dead. You notice we can still move around after we die. So look, we're at a negative health value and we're still moving. That's not good. So let's solve that problem. And the way we're going to solve that is right before the delay. So as soon as we've determined that we're dead, we're going to take away the player's ability to move the hero. Now, here we go. Right after that true branch, after we found out that the character is dead, in fact, we are going to disable input. Now, we need to feed this a player controller. So let's, actually, we could just leave it blank, because if you look in the comments, it says, if null, this actor will stop receiving input from all player controllers. So we can just leave it blank. If you wanted to, you could say get player controller and plug that in, but we won't worry about it in this case. So let's test out now. So we're moving around, and oh, they're killing us. And there we go. I'm trying to move, and I can't. So we're frozen now, which is good. That's the first part. We're frozen, and we're holding for 3 seconds while we let some animations play. So now all we have to do is set up our animation blueprint to let those animations play. Now this is where things start to get a little bit interesting for our animation blueprint. Currently, the only animation we're actually playing is the result of this hero blend space. But we need a lot more flexibility. So this whole blend space could be defined as one state of our character when he's alive and moving around. You could think of it like his state of locomotion. He's either standing there looking awesome with his gun, or he's running in some random direction and shooting the bad guys. Now he's about to be able to enter a different phase of his existence, or a different state, if you will, that we will call dead. And when he goes into his dead state, we're going to play some kind of death animation. So how do you handle transitions between these different states of being within a character? Well, you do that with what's called a state machine. So let's take all of our work here for setting up our blend space, and we're just going to delete it. I'll keep this very simple. You can right-click here in your anim graph and create a new state machine. And there it is. Add new state machine. Let's give it a name. We'll call this character state machine. And we can go ahead and wire this up, but right now it doesn't do anything, so we'll double click it. Now, a state machine is just a way to divide all of the animations that you're going to play into a series of meaningful states. Now, this is useful in a lot of ways, right? Is your character just running around? He could be in a locomotion state. Is he wounded, right? Does he have like a special animation that he plays when he gets hurt? He could go into his wounded state and then play some animations in there. And then you can blend between these different states. Now, I would suspect that the real power of state machines will not become readily apparent until you've done a little bit of animating in Unreal. However, if you open up one of the template projects like the third-person character blueprint template, then you can see there's actually a state machine in there which has the ability to run in all these different directions, as well as the various states for a proper jump sequence. So it's definitely a good place to get started. What we're going to do is we're going to begin from the entry point by creating our first state, which we will call locomotion, which is a common name you'll find on a lot of the Unreal template characters. And we're going to step inside of this. Now, this is the state that will have kind of the behavior we already had, really. It's going to have our blend space, so he'll be able to stand at idle, and he'll be able to run around, and that's all it's going to need. So let's go ahead and reestablish our blend space here. So we'll bring it in, we'll connect it. Notice this has another final animation pose, just like it does at the base of the anim graph. So we'll double click, get all the way back down. If that was a little too fast, all I did was from the anim graph, go back into the state machine, go back into the locomotion state. So we need to reconnect direction and speed. So let's go under the My Blueprint panel. Now you'll notice I'm doing a lot of switching between the asset browser and the My Blueprint panel, and you should become very comfortable with doing that yourself. So let's grab the speed variable and plug that in. Let's grab the direction variable and plug that in as well. And we can compile, and everything goes back to the way it was. So if we go back out here to the base of the anim graph, the state machine is now driving our final animation pose. But now we can get a little clever. After locomotion, we can now branch off and we can do a new state, which we will call dead. Now, as soon as you add your second or any other state after that, you get a couple of things. First off, you get your new state, and if you step down inside that, it has its own final animation pose that we're going to connect up to some network to drive animation. But you also get this little guy. This is called a transition rule. And this essentially determines whether or not the character can move from one state into another. So it's going to determine whether he can go from the locomotion state into the dead state. So this has to test true. As soon as this tests true, then we will move into the next state. So how are we going to drive that? Well, as it turns out, over in our C++ character, a long time ago when we were coding, we created an isDead variable. And we've actually leveraged that here inside of our blueprint. We used it to test and find out when the character has died. What we need is the ability to query this value inside of our character animation blueprint. And here's how we're going to do that. I'm going to take our pawn owner. So this should be the pawn that we're actually controlling. And to make it a little easier to follow the wires, I'm going to use a reroute node down here. And I'll drag another one, create another reroute node here. By the way, I'm just typing RER real fast to get access to that. I suppose technically it's faster to just double click the wire, but you know how habits work, right? So now that we've got a wire out here, the next thing I'm going to do is take this pawn, whatever it is, and we're going to cast it to the base character. That is our C++ class. Because if it's a hero, it is also a base character, because that is how inheritance works. So now at this point, we will have confirmed that this is in fact the base character. And so what we want to do is get isDead. And there it is right there under base character. Get the value of isDead. But we need a local copy of this so that we can use it to drive animations. So take the result of this, right click and promote it to a variable, which we will also call isDead. So now on pretty much every frame, we are testing to see if the character has died. And if they have died, then we can move over into our dead state. Let's set that up next. So here we are in our character state machine. We can go into our transition rule. Remember, this is the rule that determines whether we can move from the locomotion state and blend into the dead state. So let's open up the transition rule. Here's our isDead variable, and we can just plug that in. And what that means is, as soon as this state machine detects that isDead is set to true, then we'll blend over into the dead state and play some sort of death animation. And you can actually mouse over a transition rule and see a nice representation of how that rule works. Now we just need to set up the dead state. Now you could do this the easy way, right? And the easy way would be to grab like just any random one of the deaths and then just connect it up. However, you do want to make sure you don't want this animation to loop, because if it loops, he's going to just die over and over and over. So you want to turn off loop animation for this. Now you could do this, and this means that every character that dies will play the exact same death animation, which is fine for prototyping, but we're going to go one step above and beyond. Let's disconnect that. Let's bring in death 2, and we'll make that not loop, and then death 3, and also make that not loop, because you're only ever playing a death animation one time through. Okay, now we need a way to blend in, or basically randomly choose between different ones of these. And the way we're going to choose a random one is by using a special node called a blend by int. Now the way a blend by int node works is that it's going to take in some number, it's a zero-based number, that will determine which connected asset you actually want to play. Right now there's no connections though. You create connections on this node by right-clicking near the bottom of it and choosing Add Blend Pin. So now we have blend pose 0 and blend pose 1. So if we connect death 1 here and death 2 here, if the active child index, if this pin receives a value of 0, we'll be playing death 1. If it receives a value of 1, we'll be playing death 2. Now we don't really need these blend time pins. These are allowing you to control how long it takes to blend into the animation. So I'm going to come down here to my details panel with the blend poses by int node selected, and I'm going to uncheck as pin blend time. So that'll just make those connections go away. But we need one more pin, so let's right click near the bottom again and choose add blend pin one more time. And there we go. So now we have another pin, and we can connect all three of our death animations. Now what we need is some way to drive this active child index. And we're going to set that up over in the anim graph. I'm sorry, over in the event graph. I don't know why I do that. Now this is a funny thing. We have a graph here, which is essentially being called on every single update. So the value of speed is always being set, the value of direction is always being set, we're always doing this cast a base character, and we're always checking the state of isDead. What we want to do now is choose a random number between 0 and 2. So that's got three options, 0, 1, or 2. But we only want to choose that one time. We don't want to keep choosing a random number on every single update. So let's do a branch here. As soon as we detect that the character is dead, not branchy, but just branch. I can't spell it all today, can I? Jeez. So let's do a branch. So at some point, as soon as the character dies, this will test true. And as soon as this tests true, we want to do something once. And what we want to do is choose a random number between 0 and 2. But again, we only want to choose that number one time. We don't want to keep choosing a random number over and over again, or our character will start to freak out because as he's playing, he'll choose different animations to play. So after the do once, we're going to right click down here underneath and choose random int. So random integer. Now the way a random integer works is it's automatically going to have a lower value of 0, and then you just choose the max. And in this case, the max is going to be 2. So you're going to get 0, 1, or 2. Okay, and let's see. It says 0 and max minus 1. So, well, let's do 0 and 3 just to be safe. Okay, so let's now take this and we'll store it. So let's right click and choose promote to variable. And we will set this to, let's give it a cool name. We'll call this death animation selector. And we'll connect that. And we're only going to grab that random number once. So let's compile And let's go back over to our animation graph. Let's step down inside our state machine, and you'll notice we're starting to open up a lot of copies of these tabs. I end up doing that all the time, so it's just kind of how it works sometimes. If you are paying attention to your tabs, which I'm notoriously bad about, you can just jump right to where you want to be. So here we are down inside the dead state. You can use your breadcrumbs to navigate. So we can connect this blend poses by int back up to our final animation pose, and now we can choose our death animation selector, and we can plug that right into the active child index. So at a glance, what's happening is we're collecting all this data. We're collecting speed, collecting direction, we're collecting the state of isDead, and then we're testing isDead to see if it's ever true. If it ever tests true, we're going to fire a do once, so this operation will only happen one time. We're going to choose a random number, either 0, 1, or 2, and then we're going to use that to drive what death animation we're going to play. And we're only going to be in this state. We will only be able to play these nodes if, and only if, this transition rule between the two states ever tests true. And we're driving that with isDead. So as soon as isDead tests to true, then we'll pass into the dead state, we'll choose a death animation, and we'll play it. So with all that, let's test it out. So we'll compile, we'll save, we'll go back here to the arena map and play. And let's find the bad guys and let them kill us. And we're dead. And then we freeze, and then suddenly we're back. So hey, it's working. We have a death animation. And there you go. So, awesome. So that's all I really wanted to tackle in this video. We set up a nice way to select between multiple death animations by choosing a random value. That's going to wrap things up for this video. Thanks for joining us.